Now we're going to start talking about mining concepts, which is an available option in analysis services. So what is data mining? Some may call it data science in today's terminology. Analysis services was way ahead of the times by adding this feature in analysis services. A very general explanation would be that you are using statistical algorithms to mine a data set for possible ways to gain additional insights into this data that you have access to. This information is very valuable, but there are some requirements and assumptions for using the data. The nice part about SQL Server Analysis Services is that it contains a way to mine the data. There are many algorithms, and they have been verified through 5 versions and lots of users. The mining structures are standard statistical models vetted by Microsoft. The term predictive analytics is new when compared to what the cube and tabular model function as in analysis services. Before, you are showing what happened with the data in cubes or a tabular model. Now, in data mining, we take the data and predict what is to come. These predictions are only as good as the management team that uses them. Statistical models can take this data with certain parameters and group or cluster the attributes together. This discovery can show insights that are not visible with a model processed and just giving percent relevance to their groupings. Algorithms used in analysis services data mining are statistical models created from Microsoft based on mathematical statistics common in the industry. Mining structures are created with a data source, just like cubes or a tabular model. Those data sources then contain tables, views, or related tables that give you the information to model. The most useful structure will be a table structure that has a key with predictable attributes. Knowing the structure is key to using SQL Server Analysis Services for data mining. The uses of data are split into 3 areas. The first set will train the model. The second set is used to validate the model created with the training data. Then the real data is used to predict the outcome from the trained model data and the validated model data. What we're going to have to look at when using data mining is answering some questions from our business. The business question determines the algorithm that can be used. This takes practice. The structure of the data is also important. The Microsoft decision tree algorithm needs to have 3 things: a predicted column along with a key to each row of the data, and the data containing discrete or continuous attributes. Here are some questions you might typically hear from the business side. What would the customer buy, and will he buy a certain product? Here we gather demographics and survey information from a set of existing customers and a product we sell that they either bought or did not buy. These attributes might be education, like school level, others like number of children, age, and house owners. These attributes can be related to if the customer bought a bike or did not buy a bike. Product grouping is a very popular way to get customers to buy items by placement in a store. A statistical model can be used to see if placement affects the way consumers purchase products. Online stores use this all the time to suggest other purchases similar to what the client has already selected. A big deal in the industry today is fraud detection, and this is not about similarities as much as it is about oddities. So, some algorithms show outliers to a pattern for, say, credit card customers. If a customer purchases an item in a town of residence, then a purchase hundreds or even thousands of miles away on the same day might not be valid. Other patterns can include price increases or decreases that show a significant change in the number of purchases or in the profitability of the purchases. We might be able to tell if raw material prices go up, what percent we can use to increase the sale price without affecting profits. Popular statistics are regression lines and time series events, and these will be useful for many industries and are available in addition to what we've already talked about in SQL Server Analysis Services data mining. There's a language behind data mining called DMX, which is the Data Mining Expression Language. This is a language that reporting tools can use to further expand into the data provided by a data mining model. Most customers have some sort of client development that is custom to their system, so they can use this language just like DAX and MDX to retrieve the data from a mining model or an analysis services database. The SQL Server Management Studio, SSMS, has templates to help you build the DMX language needed for these reporting or client development. And here's a simple query that looks at the node distribution for a bike buyer based on the age. So it's just like or similar to a T-SQL or MDX where you select particular attributes from a database or a mining model content and having a where clause where you can show the attributes of age and total children and order it by a particular attribute. Data mining has many types of algorithms. Classification involves predicting the value of more than one fixed variables based on multiple input variables or attributes. These types of algorithms are often used when a business has a large volume of high-quality historical data. Analysis services includes the algorithms most often used to implement this technique, like Microsoft decision trees, naive Bayes, and neural networks. The naive Bayes algorithm is based on a naive independence of the particular attributes. On the other hand, the neural network is often used with very large volumes of data that have very complex relationships. With this type of source data, the neural network algorithm can produce the most meaningful and useful results as compared to the other algorithms. Clustering involves grouping the source data into categories, sometimes segments or buckets based on the values supplied. All the attributes have an equal weight when determining the buckets. This group of algorithms is often used as a starting point to improve an end user's understanding of the relationship between attributes in a large volume of data. Businesses also use them to make more intelligent like-for-like predictions. For example, store A is like store B in these categories, so it should be performed similarly in this category. The Microsoft clustering algorithm is best for this type of analysis. Association involves finding correlations between variables in a data set. This is often called market basket analysis. The goal of the algorithm is to find sets of items that show correlations, which are frequently based on the rate of a sale. For virtual businesses, the results can be used to improve the click-through rates for advertisement. Analysis services includes a Microsoft association for this implementation. Forecasting involves a process to find similar classifications, i.e., predicting a value based on some multiple input variables. Businesses may forecast or use regression algorithms to predict the sale of an item based on the retail price or position in a store. Analysis services algorithms are the Microsoft time series as well as the linear and logistical regression. You can use these to fit data points for the best possible line while the logistics regression fits the data points to a curve. Sequence analysis has finding patterns for particular subsets of data. Businesses can use this algorithm to involve and analyze a click path of end users to their commercial website. These paths or sequences are often analyzed over time. Analysis provides Microsoft sequence clustering for this. And you might answer a question, why did a customer buy on a second visit? The sequence and association algorithms both work on these types of instances. The last category is deviation analysis. This involves exceptional cases in the data. In the language of data mining, these are often called outlier cases. Businesses use this type of algorithm to detect potential fraud. One example is credit card companies who use this technique to initiate alerts to their users when something out of the ordinary happens on their credit card. The most commonly used algorithms for this type of analysis are the Microsoft decision trees used in combination with one or more algorithms, often Microsoft clustering. Now let's look at a demonstration of a data mining project. First, we're going to open up SQL Server Data Tools, which is an icon on our desktop. Next, we're going to open up the Analysis Services example database, AdventureWorks DW. There's actually a project out there with some data mining already created for us. We're going to open up the Enterprise Edition, which you can download from Codeplex if you'd like. In this project, there's going to be multiple mining algorithms already created for us. The structures are customer mining, forecasting, a market basket, a clustering, sequence clustering, and a targeted mail. We're going to look at the targeted mailing first. That's one of the easiest, and I'm going to pin back some of these displays. Here we see that a view created this original mining model. If we right click, we can actually go edit the data source view. And here we can find that table or that view if we need to. Targeted marketing is a view created inside of Analysis Services. It is a join of the fact internet sales along with some dimensions. And then the view looks at data that is specific to bike buying. So the category is for bikes. And if we eventually get to the subcategory and category columns, we can see that available in the target mailing view. We'll close that and go over some of the other tabs involved in this mining structure. The first one is where you actually pick the attributes, the predictable column, and then also the key. And if we go to properties, we can see that selected. For instance, for age, we see that it's desecretized, which means it's going to do some bannings on that. But if we go to bike buyer, we'll see that that is a discrete long, but it is also the indicator of what we're looking for. We're looking for a bike buyer. The other attributes are going to be discrete as well as a key, which is customer key. So for this view, each row uniquely is identified by a customer key, and if that customer bought a bike, and then the demographics about that customer. The yearly income is a content type which is called continuous because the values are continuous, whereas something for like total children is going to be discrete because there is no continuous flow of the data. I'm going to pin back the properties and go to the next tab, which is the mining models. So when you first create an Analysis Services data mining model, you will only get one mining model to choose from. But afterwards, as you can see here, we have a decision tree, a clustering, naive Bayes, and a neural network. If we right click in this tab, we'll see the ability to add new mining models to this mining model project. We also could tell it what an input value is. Do we ignore the value? Is it the key? And it is the predictable one. You'll notice here in one of these mining models, that is ignoring one of the columns. That is because the mining model can't handle that type of data, which is yearly income, which is continuous. So each mining model that you pick, the default algorithms have requirements. One of the big requirements here is a key, a predictable, and then inputs. Once we have that and this model has been processed, the next tab is the mining model viewer. And when we go to it, it's telling us that our mining model is out of date. Do we want to deploy? And we'll click yes. And it's going to take a little bit of time because this is a huge project inside of analysis services. And it's going to look at anything that needs to be updated. And if you notice in the lower right, we get the deployment is successful. I'm going to make the properties a little bit smaller for us to move to see more in the view. And you'll see now we have a display of the decision tree, and we're viewing it based on the Microsoft Tree Viewer. Every mining model has a Microsoft generic content tree view, but this is just a text way to look at the mining model. Most have a visual one that's available, and that's usually the one you select. If you notice to the right, we have a mining legend. In this mining legend, we see that we have values of 0, 1, and missing. This determines if a bike was bought. So the value 1, we have 9,132, which is about 49.5% that actually bought a bike. And that's if we're on the level all. We'll also notice here you can change your tree to whatever predictable column you want selected. So even though this model had bike buyer as the predictable column, you could have multiple predictable columns and select them here. There's also the amount of histograms you want displayed, as well as what kind of background shading do you want. So if you notice, we changed the background to 1, which means the person bought a bike. We'll get a little more view of the shading to show the significance of that particular path if the person purchased the bike. So if you notice down towards the bottom where number of cars is 0 and Pacific is region, we seem to get a 91% probability here. We could even drill further to see in the Pacific region what significant attributes show who buys a bike and who doesn't. And in this case, the model says if total children is not 4, which means every other value except 4, then there is the greater probability. But if the children equals 4, it's about even whether they buy a bike or not buy a bike. That's our decision tree view. If we change the view to clustering, we'll see a different graphic. We'll see the clustering of attributes. And as you hover over one or another, you'll see the value that's inside of there. You also have a slider that can kind of take away some of the insignificant relationships between clusters and also show more, as well as an ability to move these clusters around to see what related clusters move with them. We'll change from clustering to naive Bayes, and we'll even get a different view. Here, the center part is the buyer, and there's a legend on the bottom to show us what the different colors are. We selected the bike buyer node, and the other light brown color is the nodes that predict this node. Again, we have a slider on the left that lets us take the less attributes that are significant in the predicting of a bike buyer away until we actually get to the first attribute that's most significant. So apparently, using the naive Bayes, number of cars owned and then age are the most significant attributes that show if a person is going to buy a bike. That way your marketing team can concentrate on age and number of cars owned to advertise to these type of customers. The next one we'll look at is neural net, and again you'll see a visual display. Here we have histograms of the most significant attributes towards someone buying a bike. In this case, that's our only output attribute. You also could change the values that are displayed here to compare if there's more than one value for the predictable. And if you notice in the neural net, one of the most significant things is age. And if the person is greater than or equal to 91, it is the least favorable to actually buy a bike. So here we see that 81% of the people over 91 do not buy a bike. This is just some of the displays of the targeting marketing model that we built. And again, there's others like Market Basket, customer mining, and forecasting. So as you can see, there are plenty of different available items inside of analysis services to start mining data. And again, you get different visualizations of what the data actually means. And here we have a forecasting that gives us a graph of what things look like. In customer mining, we have a different type. We have clusters, and then we have subcategory associations. And so what you need to do is spend some time with your marketing team or your advertising team to find out what the best algorithms are. Again, the data can be used partially to train the model. Another part of the data can be used to validate the model. And lastly, you can join to another table, which is this tab, Mining Model Prediction, to actually show the model versus another piece of data with similar attributes to see if you can determine who's going to buy a bike.